Let's talk about solids. A solid is a three-dimensional shape, and it comes in all sorts of shapes and sizes. A polyhedron is a type of solid that has flat surfaces. So we're not talking about curves at the moment, we're talking about flat surfaces. Poly meaning many, hedron meaning faces. So here's an example of a tetra. Tetra is 4 faces, tetrahedron, and these things are named after the number of faces. You have a triangle here, and then behind it or in front of it, depending on how your perspective is, you have 3 more. A hexahedron has 6 faces, top, bottom, side, 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 side. Vertices are the points, so that's the points here, and edges are where the faces come together and meet along here. So there's this crazy guy, he wasn't crazy. I say Euler, you say Euler, whatever works. He sort of worked out that there's a special relationship for all polyhedrons. Polygon is flat, two-dimensional. Polyhedron, or polyhedra plural, is a 3-dimensional thing that has to do with the edges in relation to the faces and the vertices. So for any polyhedron, you can find the edges by taking the faces. Let's go with this one, 4, plus the vertices on this tetrahedron has 4, and that gives us 8. We subtract 2, and that gives us 6. And sure enough, there's our answer. And the same would work if we added the faces of this hexahedron, 14, take away 2, and that gives us 12. Now there's a number of different types of polyhedra. Prisms will have the same shape at either end. So this one has a hexagon, the 2-dimensional form, but it becomes 3-dimensional when you connect that with these additional faces, and you get a hexagonal prism. If I had a 7 heptagon on the bottom and the top, I'd have a heptagonal prism. Pyramids are like that. They're also named after the base, but they don't go from one shape to the same shape. They come up to a point. So this is a square pyramid because it's got a square at its base, and then it rises up to a point from there. I'm sure you can read these and see the different names for these other shapes, and that will help you when you're doing your work down here. When you're classifying these, they're classified by the number of faces, and as this one shows, there are a few little tricks to how we can name them differently. So a few names I scribbled in here. Because it has six sides, this polyhedron is a hexahedron for 6. It could also be called cuboid, which is a common name for a rectangular prism. Remember, just like the hexagonal prism, has the same shape at one end and the other, and it's connected. This one is a heptahedron because it has 7 sides. You might be thinking, wait a minute, that's a 5-sided pentagon there, but that's one face, and each of these adds up to 7 faces. But you can also call it a pentagonal prism because it's a prism that's based on pentagons on either side. So let's finally use Euler's rule to find the number of faces on a polyhedron that we know has 10 edges and 6 vertices. So plugging in the formula, edges equals faces plus vertices minus 2. We know the edges are 10, and so we're actually solving for the number of faces. So 6 minus 2 is 4. F plus 4 equals 10, therefore F must be 6, and there's your work.